Hello physics students, this is Mr. Steinerson, and on this short video I'm going to overview some of the main ideas when we talk about graphs that are important for us to understand when we're going between distance and velocity graphs. The first thing is when you identify your distance and time graph, the slope of that graph is the speed. Now we're going to talk about velocity as also including direction, but that will tell you the speed in that given part of the graph. The steeper the line, the faster it's going. All right, so if we have an object that is stopped, I'm looking at the slope of my distance time graph. I have distance time on top, I have velocity time on the bottom, and notice the slope is 0, therefore the velocity over that interval will be 0. Similarly, if I have a constant speed, the slope of my distance graph, notice how it doesn't change, it's a constant value, and it's in the positive direction. It's a positive slope. Therefore, my velocity graph will need to be in the positive quadrant, but it doesn't change, so it would be a straight line in the positive. If we're talking about negative direction, notice the slope is inverted. It's now negative. Therefore, my velocity will have to be a constant negative value. So the positive velocity tells you the direction it's going. Often positive velocity is to the right. And the negative velocity tells you that it's going in the opposite direction, often to the left. Your velocity graph will tell you both the size of the velocity and also its direction. If we take a look at a graph that's speeding up or slowing down, we can use a similar idea using the fact that the slope of the distance graph, where it becomes tangent to the line, is the speed. So in the beginning of this graph, my tangent line does not have a very steep slope. In the middle, it's getting a little steeper, and at the very end, that tangent is pretty steep. So I would be indicating that it's starting slow, going a little bit faster, and it's the fastest at the end. So I have to show that with my velocity graph by drawing a velocity that starts low and ends high in the positive quadrant or the positive direction. So I'm going to start at 0 and I'm going to end at some higher velocity in the positive. Now, if it's speeding up in the negative direction, it just means it's coming back towards maybe the origin. It's starting far away and coming back towards. Again, we can take a look at the tangents. In the beginning, my tangent is almost flat, then it becomes a little steeper, and it's the steepest at the end. So my speed should start low in the beginning and then increase. But now we're in the negative quadrant, so I'm going to start low and I'm going to increase. It'll look something like this. Lastly, if we're slowing down, we are going to be decreasing our velocity. Similarly, I should decrease the slope or the tangent on my distance graph. And sure enough, if I draw those tangents in, I start steep and I end shallow. So it's going from fast to medium to slow. I need to represent that on my velocity graph as well. So if it's in the positive direction, I'm going to be in the positive quadrant, starting at a high velocity, and it will be a uniform decrease to maybe 0, where it's a flat line. And if it's in a negative direction, I'm going to start at a high velocity. Notice in this graph, I have a high slope, a medium slope, and a 0 slope. So I'm going to do the same thing with my velocity, but it's in the negative. So I'm going to start far from the origin and come back to where the 0 would be. Please let me know if you have any questions, but use this idea of the slope of your distance time graph will tell you the speed. If it's in the positive quadrant or the negative quadrant, will tell you the direction for all the velocity graphs. Thanks and have a great day.